Okay,
Perfect.
so
Thank you.
let's go ahead and get started. Let me start here. Okay, so this is the last pattern you will need for your assignment too. Okay, after that you should be good to go. I received a couple email about asking the assignment 1 and 2. If you can, let's chat about after class because some of the questions are too technical. I don't know how to explain that through email. So we probably need to talk that after the class. Okay, just feel free to let me know. I will be available. Right. Sound good. All right. So visitor pattern. Okay. So the intent is that we want to represent an operation on elements of an object structure. Lets you define a new operation without changing classes of the elements on which it operates. Okay, it's too formal. Okay, don't get it. Let's forget about the definition. Let's just dive into the examples. All right. So the first motivation example from the book, okay, is about this abstract syntax trees. I don't know how many of you learned this one. I don't know if you teach this one in programming language course. And then if you ever took a compiler course, has anyone took a compiler in our department? I know they offer that once every a while. I don't know how frequently. Nobody took a compiler course before? Yeah. So yeah, if you want, I think we will offer that, once every year or 2 year, depending on certain faculty they want to teach it. But in when I was in college, okay, guys, at that time, the compiler should be kind of a core course that everyone need to take. And also, at that time when we do the senior project, kind of a senior project, these days you can really do any kind of thing, mobile, web, everything, right? But back then, we don't have that many kind of options. There's no AI, machine learning stuff. There's not much you can write. Okay, um, making a compiler project was very very common. And then also, I have told you, making a compiler is probably the most difficult kind of project you can ever do in the undergrad. It's a very complicated program, okay, because you need to deal with parsing the syntax, you need to know how to verify the grammar, and then you have to translate the code into some other kind of a code that can be executed, and then you also need to optimize a lot of the translation process. So if one day you can build a compiler, then you're really a very good programmer, and you can probably call yourself a computer scientist. Okay, that means you know a lot of things about computer science. It requires a very comprehensive um, range of knowledge, in order to build a compiler. All right, but anyway, one step you build a compiler is that once you take your whole program source code, now you need to break them down and represent them into this kind of tree type of structure. We call them abstract syntax trees. All right, basically, this is how we can later on verify the syntax, if the syntax is correct. And you can see this is a little program here, the while loop, return something. I think this is written in Pascal, the older language. And then, for this tree, you should have a bunch of statement sequence. You got a while statement and then the return statement. So basically two statement, but the while statement has a condition and also body. The body could have more like a code. There's if statement, else part, condition, all of those, right? So you basically break it down, store them into the tree, and later on you will learn a lot of algorithms to traverse the tree and then verify if the grammar complies with the grammar you defined. Okay, so that is a kind of abstract syntax tree. Now, once you get this tree, we will often need to do a lot of operations on top of this tree. Things like how do we check if the type are correct. Okay, that's very important thing for a lot of the type languages, like in Java. If you declare this variable as integer, you cannot assign a string to it, right? So you need to make sure the type are all correct. Later on, you might need to generate the code. That's something else I mentioned. You write Java code, but eventually it will be converted into a Java bytecode so that it can be executed in the Java virtual machine, right? So that process also, you need to go back to the tree to visit every single node and then generate the code. Other things including a pretty print. For example, you write the code and then you want to adjust all the indentations, spaces, everything. So that means you have to go back here to figure out their structure and then insert or delete certain kind of spaces. So this pattern is in a context that you have this kind of a date structure here, and then you want to perform a few different kind of operations on top of each node. For example, again, to summarize, type checking, you go through the tree, make sure all the types are right. Pretty print, you go through the tree and make sure you actually clean up all the spaces. Another one is code generation. You go through the tree, and for every node, you generate the code for it. Right. So this is the kind of a situation we're talking about, right? So that's why one kind of a structure you can do is that you build this kind of a node class, then you put these three methods there. So for different type of a node, for example, certain nodes are about a variable, certain node about assignment, certain node about like a statement, certain node about operations, and then that's fine. As long as there's this kind of a node in the tree, you will just need to implement this method to make sure that we can perform these operations for that specific type of a node. Right. So this is how we can build this with one way, which is a very straightforward way using the inheritance. Okay, so this is the context. However, we don't think this is the ideal way to build this kind of structure because if something got to change and this structure might not deal with that change very well, the most important change is what if we need another kind of operation? Okay, beside the pretty printing, what if we want to do like optimizing code or checking runtime error or something like that? And then you will need to add one more method at the top level. And that means all the subclasses need to be changed by adding that new method. Okay, so that will be involving a lot of changes on different files in every single class. So that's the part we don't want to see, that if you need to add, modify your operations that to be performed on top of this tree or some kind of data structure, and then the traditional like hierarchy like this isn't going to work very well. And then this pattern try to help us to build a better structure to deal with that kind of changes, so that you don't have to touch those nodes. All right. So let's do this very specific example that's very easy to understand. I really like this example, very clear. So let's talk about the cars. Okay, let's think about like, oh, we have in a different component of the car. We got a wheel, we got engine, we got a body, and then these different components we need to perform some operations. Maybe every once in a while you need to upgrade them. You need to just do the regular maintenance. You need to check if there are any recalls for all of them. For every component, you will need to do some of this. All right. So how we're going to deal with that kind of situation. So let's start with building this kind of a structure first. Okay, so I'm going to go back to Eclipse. Let's take a look at this example very quickly. All right, so I'm going to start a new Java project. Its name is called Visitor Pattern Demo. So I'm going to create my first package. I'll call it like V0. So I'm going to start from building the data types. Okay, so I will have a tree, engine, body, and a car. Car is going to contain the other parts, right? So let's actually build the individual classes first. Okay, so this one is a wheel, right? And for wheel, I'll just do some random attribute. I'll call it brand. Okay. Now I'm gonna do engine. Engine, maybe there is a type. After that, we have wheel, engine, body. Color. All right, so that's the three components. And then we also have a car that includes everything, right? So we're gonna build our car. Obviously, a car could have all of these components. Now, a first approach you can do is you could have, a list of wheels. Right? You could have one engine. Also, you can have body, okay, one body. Right? So that's one way to do it. Now, if you remember another pattern, now we told you this is not very good because you have, if we're talking about other component, you have to change this one. I'm gonna do the steering wheel. I need to do the dashboard, all of this. Then you start to add this more and more. Okay. So a better way to deal with this situation is, first of all, if they're all the same kind of a type, why don't we just group them together into one hierarchy, right? So that's why it will be better to make something like a auto element, right? So I'm going to build an interface. I'll call this auto element. All right. For now, I'm not going to add anything yet. So I will just do, okay, body will be a type of auto element. Car and engine will be an auto element. Wheel will be an auto element. All right. Now, if you have this, the car will be easier to build, right? So I can just do a list of auto element. Just say that element. Then you really don't need to worry about others. And then we can do it, etc. All right, so that's it. So to clarify, okay, so we got a hierarchy here, auto element, and all of these are the same type. So the car could just include a list of them. And then if you want, I can also make a car as a auto element. Okay, to consider them to be the same type. And then again, the advantage of doing this one, you're gonna have a more flexible, containment relationship. Like a car could contain another car, but that's not what we want. Okay, but you can start to see some other benefits of doing this. All right, so I hope everyone can see what pattern is this one, the way we build this car structure. This one here, guys. Which pattern are we using? Yep, so that is the GUI example we did, right? So this is composite pattern. All right, composite pattern is very simple. It just try to give you a way to build a hierarchy to model the individual type of components and then the container type of component and merge them into the same hierarchy, just like this. So everybody is auto element, and the containers can contain a list of elements, but can also contain itself. All right. In this case, again, you don't want to model the car to contain another car. But in a lot of situations, you will find that to be much more useful and effective. All right. So yeah, so we use a composite pattern to model the data structures and relationship, but then the visitor pattern will come in for a different purpose. So I'm going to show you that motivation. All right. So any questions on this part yet? On this hierarchy? A very simple car example, okay? 3 components, 1 container, 1 interface. All right, so yeah, we'll talk about the assignment later on, all right? Yeah, the car cannot contain another car. So you can do this one or not. It doesn't matter too much. And I'll explain why we're putting this one here first, okay? So this is the base code, all right? So let's take a look at the actual actions, okay? So what we want to do now is every of those component, we can call some function, do the maintenance, check recall, or do the upgrade. Okay, for all of this, we can do this. All right, so I'm gonna make a copy so that we can differentiate them. Okay, I will do a V1. All right, so I'm not gonna mess up the other code. All right, so in V1, I'm gonna add those. All right, a very straightforward solution would be, now think about that, for example, for body, you need to do a do maintenance. All right, and then you will need to do check recall. And finally, you have upgrade. All right, so this method. So that way you can perform these operations. However, we want the same thing to the other part as well. For that, like for engine, you also need this, right? So that's when you start to see that this method should actually go to the interface. So I'm going to put this one into the interface. All right, and obviously in the interface, you don't have body, just the signature. All right, so that way, okay, so body we already implemented, it's perfect. Engine, we got it right. And then for the wheels, we just need to add it. All right, so that way. So this way it's to checking recalls wheels. Okay, so we'll finish this one. All right, and then since I put the car under that hierarchy, that means the car also need to implement it, right? That's why I put it here, because you can also just say, okay, I want to do the maintenance or recall for the whole car. So the car will just iterate all the other elements. Okay, so for example, you can do something like auto element. And then you do maintenance, right? So that way you can just call all the children's method. This one to check recall. Finally, you can do the upgrade. All right. So that's the structure. Again, this one is not really required, but then if you add it, it's just basically use the composite pattern. You decide if that makes sense or not. But one advantage is that this one also has this method. You can call this method on any of these elements you want. All right. So that is one kind of way to build this kind of structure. And then you can see you abstract this behavior and operation in the parent class. So all the others, now you can call them anytime you want. Now, this is actually a very clear and good structure, especially you also use a composite pattern. Okay, so not bad. But then the problem, going back to the pattern, as I explained, all right, so previously you had a 3 operation, you can check the type, you can generate code, you can pretty print. But what if I want to do another one, like optimization? What if I want to do another one to say that generate a comment? Okay, now here's the same case. Besides all of this, what else we can do? We can do for car, just I don't know what else we can do for the car components. What did that mean, Christian? Pin my right. What did that mean? Oh, okay. All right. Yeah. So Well, just to say replace, I guess, it's a broken. All right, so let's say the replacement. So if you want to add a new operation, that's when the issue happens, right? So I put the new one, I will call it replace. Okay, so then you will need to add this method here, and then immediately you're breaking all the other code because you don't have this behavior, and then you have to add those, right? And then this one here, we do the replacement, replacing the body. Okay, so you need to add this one to every single class. For engine, do the same, and then for wheel, and then finally for the car. So this one you simply just call the others. All right, so that's kind of the problem we're talking about here, guys. So every time when you try to add a new operation, then you have to go back to all of these classes to add it. Okay. And then that's kind of a change we don't want to see because this is only 4 classes. And you think about the car, in reality, there could be, I mean, thousands of components there. And then if we decide to add one method, then you have to go back to 1,000 files to add this one method. That's going to be quite a lot of work. Or later on, we don't want to use any of this method. That's going to be a disaster. You have to go back and then delete all of this. Another thing you see here is totally like duplicated, right? So it's same structure. It's basically just calling different things. All right. So the more operation you're adding, the more issue you can see about this structure. Right. So now we're just asking the pattern on telling us how can we improve this one to deal with kind of a change in a better way. So that's why you should always keep in mind that the design pattern always help you to make the changes simpler and easier. Okay. So we go back to slides. All right, let's take a look at the visitor pattern. So this is what the visitor pattern tells us. All right, to solve this problem, and there's the root kind of a solution is that we shouldn't actually merge these two things together. Right now, what's happening is we got our data structure for this hierarchy using composite pattern. But same time, we're also merging all this operation into the same hierarchy. That's what we're building. Now, this one looks very straightforward, but it just makes your change very difficult to perform sometimes. Now, what we should do is split this one into 2 hierarchy, where the previous hierarchy only deal with the structure, and then the operations will be in a totally different hierarchy. So if you want to modify some of the hierarchy, the behavior and the operation, you only need to change this one part. Now, this one also kind of applies to the single responsibility principle that you shouldn't merge too many things together. And then if you did that, this is kind of an issue. It will make some of the change very difficult to do. All right, so let's take a look at the visitor pattern. So you will need to split them, all right? And this one here, you can just have one method called accept some kind of visitor, and that's it. And then you move all the code about operations to the totally different hierarchy. Like here, you got a node visitor, and then you will need to specify what type of nodes are there. You need to define in terms of different type of visiting operations. And then you will implement this visitor for all different kind of behavior and operation. Okay, so that's basically how the code will work. Okay, so these are all the explanation, but let's actually come back to the code to show you the better solution. So with that, I'm going to create a V2 using the same code base. All right, but this time I'm not going to do the hierarchy like before. So I'm going to follow the pattern to design something called node visitor. Okay, so I will create another interface. I'll call this auto element visitor. So for this one, you will need a few methods to visit different type of things. Like right now we have body, car, and engine and wheel, so you need to define those. Visit body, visit engine, visit wheel, and also you probably visit car. Car is very special. Okay, so we'll look at that later. All right, so that's what the engine will requires. All right, and also, sorry, not the engine requires, the pattern requires. But at the same time, it actually asks you to actually pass the specific node you want to visit as a parameter, so that's easier for your node to write it. Okay, so in this case, that means this one here you need to provide a body, this one here you need to provide an engine to visit, and this one here provide a wheel to visit, and then finally do a car. So that's how we're following the pattern. Okay, once you got the visitor interface, and then let's actually implement the different kind of visiting operation. As I mentioned, we got a maintenance, check recalls, and upgrades, 3 different kind of operations. So I'm going to do that one by one. So the first one is called a maintenance. Visitor. All right, and then you will implement auto element visitor. All right, so we use one class to only to just write all the things about certain operation together, to put this part of the code together, rather than spreading them into different node classes. All right, so I will just add all the implemented method here. So this one here, you're gonna say, okay, I'm gonna visit maintain body. Okay. This one is the engine. This one is the wheel. This is the car. This one is a little bit special. You actually have to basically go to let's leave this one here at the end. Okay, the car is a little bit special. Let's leave it here. Okay, just look at how the pattern works first, and finally we'll figure out whether we do it here for the loop or inside. All right, so that's one. And then this is one type of operation. Okay, it's all about maintaining things. You maintain different kind of components. And then I can do the next one, which is check recall. Check recall visitor. And then this one also, you will need to implement auto element visitor. So this time we're just dealing with checking recall. All right. So this is again a dummy implementation. The truth is actually they gave you the body, so you can actually do anything you want from the body given that information. So you have the access from here. All right. So let's do last one, which is upgrade. All right. Upgrading body. So now this is how we follow this pattern. Okay, so a separate hierarchy just for operation, but then you have different methods to visit different type of things. And then for every type of operation, we have one class to deal with that operation on top of every single type. Okay, so that's how we can, build this kind of hierarchy. Now we got a tool hierarchy. Okay, we got a visitor, and then we got the data part. And now we need to solve the problem on how the data actually uses visitor pattern. So as you can see, they actually gave you this specific code. All right. So you're gonna receive that visitor, the node visitor. Every kind of a node, you will have this method called accept. You accept certain kind of visitor, and then we're gonna pass those visitor. Then you can use that visitor to visit yourself. All right, so let's write it down and then you will see that very clear, okay? So right now this structure has nothing to do with this part, okay? So I'm gonna define something called accept, meaning that I can accept some kind of visitor, right? So we did this one, all right? Once you have this, make sure all the classes have the same method, okay? For example, body, you need to have this kind of thing to receive and accept some kind of visitor. So we're gonna send you a certain visitor, but you don't know what. It doesn't matter. I can give you a recall, I can give you an upgrade, I can give you a maintenance, but it will be a visitor. So you don't need to worry about what type of visitor it is, but what you need to do is you need to make sure that you have the visitor to visit yourself. Since you're a body, you're gonna say visit body and provide yourself. Okay, so you send yourself the reference over to the visitor so visitor can take your information and do whatever they need. All right, let's see the engine. For visitor being passed, I'm gonna visit engine and then pass myself. For wheel, same thing. Visitor, visit wheel, and then pass itself. All right. Okay, and finally for the car, we just need to iterate everything. Or I think maybe for the car, no, we shouldn't iterate this one here. Let me think about that one. If we do the iteration here, let me think. No, we can't do that one here. So this one will be a specific just to visit the car, I think. Yeah, let's do this one here. All right. So now I'm done with the visitor pattern. So how this whole thing works, I don't know if you guys see this. All right. So you got two hierarchies, and then the visiting, the behavior, all in a different hierarchy. So let's actually put a driver and try to run it. Okay. All right. So we got some of the car. Let's build some engine. And then we got a wheel. Four. Then you got the body. So we can have a car. And then we can put all the elements there. Okay, so we form one car, and then if we want to do, for example, now we want to check the recall, right? So we're gonna do a bit of the pattern here, which is called auto element visitor. Okay, so this is the check recall. Right. And then we want to check that one on, well, let's try it on the individual ones, right? So for the E1, all I need to do is to accept the check recall visitor. And that's going to check that one for the engine. All right. And then you may have an upgrade. Right. And then for E1, you can also say, okay, I want to do the upgrade. Yeah. Something like this. All right. So the most biggest benefits of doing this one is that your data part here remains the same. Okay, your car, sorry, the body, car, and then engine and wheel. This one you don't have to change anything, no matter how you change the operations. Like we mentioned that you can do the replacement, you can do the fix, add oil, all of those. Those won't affect this kind of hierarchy. All right. So for the car, for this kind of thing, I'm still thinking what would be the good way to deal with it. So if we do this one here, it's actually with the car, and that means in the car we do need to perform that. Yeah. So maybe it makes more sense to do it on the other part. So here, for the car, you actually should iterate, all the elements from here. Car get all the elements, right? And then you use that element to accept itself. Yeah, something like that. So this one could be good. Okay, so let's actually clear this. So for the car, since you have all the other elements, so besides checking the car, and then you also want to iterate all the others, if this is the logic you want to do. Okay, if not, then just do this one line, fine. This one here, I'm just thinking, how can you simplify the other part? So we iterate all the element, we let them to also take this visitor operation. That's it. And it doesn't really matter, because if you pass this specific check recall visitor, and then they're gonna take it and they will run it on their side. I think that's the way to go. All right, so this one should be the same for everything. So maintenance as well as upgrade. So for example, if we try to say that, okay, so car one should be try to do a check recall. Okay. So we don't have to do this one separately. And then if you run it, okay, so we're checking recall for car, for engine, for wheels, for body, for everything. And then if you say that you want to do upgrade, all right, and then run this again. Okay, so now you do all upgrading for everything. Okay, so figuring out how to call this one shouldn't be too difficult. But the benefit again is about the changes. Okay, so as we mentioned that, oh, now we want to do another one called replacement. Okay, previously, remember you add the new method here, then everything got to be changed and updated. Now I can just add another visitor, right? So let's see that. It's called replace visitor. Now this one is going to implement visitor pattern. right? And all you need to do is figure out how do you replace them. Okay, so replace the body, and the engine, wheel, and then the car, right? For replacing car, you can still do a for loop or not, doesn't matter. So you control that part of the logic. Okay, but see this time when we are changing the operation by adding a new one, this is the only change you do. A a new class you created for this new behavior, which is replacement. None of the other classes will be changed. Okay, like you can directly use, once this one is done, you can start to use this one here. Okay, you can then do just auto element visitor, and then this is replace. What do we name for that? Replacement. Probably didn't save it. Right, and then you can just have them to do the replacement. No others need to be changed. All right, so replace the car. Okay, so that's kind of the situation we want to get. Even though the previous version was okay, you use a hierarchy, but it doesn't, handle the change in a very flexible way. Now with this visitor, then you can just do, all of this in one place only. That's what this visitor pattern is trying to tell us. But then the really the core idea here is that we're trying to separate the data structure and the operations that's going to be performed on top of this data structure. They shouldn't be in the same hierarchy. And that's the benefit you can gain by doing this. All right. However, as I do this one, can anyone see a drawback of building this kind of a visitor pattern? Even though this visitor pattern handle that kind of change really well, right? So if you want to add a new type of operation, it's very, very clean, just like I mentioned here. Build one class and then you're done. It doesn't affect all the other things. However, this pattern also has limitations. Can anyone see a potential downside of using this pattern when it handles some kind of changes? Yeah, very good. So adding a new car element. So right now you see for every visitor, you had to implement that method to visit every different type of node. Okay. If we don't change the node, that's good. However, if one day want to add another one, okay, we're adding the steering wheel, we're adding a dashboard, then this structure is still going to be modified in every single subclass. Okay, so for this pattern, so basically the ideal case is you have this tree ready, just like abstract syntax tree, the class already defined, you're not going to modify that very often. And then you use visitor pattern to separate the operations. However, if your tree is not even fixed, then you have to wait on building this one. So every single pattern is not perfect, okay? It deals with one specific change for certain contexts, but you also need to understand the downside so that you can figure out a trade-off and decide what's the best one to use. Okay, so that's a very important point to keep in mind about the visitor pattern. All right, now as you can see, this pattern we ask you to apply it in assignment 2 for the feature I mentioned last time. So in the main control panel, okay, so you have Make it a little bit bigger. Okay, I put these 4 buttons here. Okay, you click on this button, will show you how many users in total. Click on this button, will show you how many groups are in total. This one shows how many messages all the users have posted. This one shows how many of the messages are positive. So all of this button share something in common, that they have to iterate, go through all of these elements and perform some kind of operation, even though it's very simple operation like counting, right? So mostly counting and then analyzing the text, right? But it is applying some kind of operation on top of a certain node, okay? Whether it's a group or it's a user. That's where you can apply this validator pattern. Okay, hopefully you can see that. And then composite pattern is not necessary to be applied with the pattern all the time. It depends. Like in this case, this car example, you really don't need to include a car into the same hierarchy. That's fine. But for this example, the composite pattern is definitely something you must use. Otherwise, you can't implement this kind of a containment relationship with different levels. All right. So to summarize, for assignment 2, singleton pattern is easy. You basically have to make this element panel to be singleton, one instance only. Composite pattern will be applied to this user and group structure. Okay, and then visitor pattern will be applied to implement these 4 buttons. On the other page here, all the updates, the follow, tweets, updates, that is taken care of by the observer pattern. Okay, so when we are looking at if you are applying the pattern, it's really easy. All we're looking at is for example, the visitor pattern. Do you have this parent class for the visitors? And then do you have all the implementation for those as a hierarchy? If you have, then yes, you apply visitor pattern. Composite pattern, simple. You need to have some kind of a parent class name. You need to make sure all the subclasses or child classes belong to that one type. And individual components belong to that type. Containers also belong to that type. And the containers can go back to contain other element. All right, so as long as you have those kind of a parent classes, inheritance relationship there, we know that you apply this pattern. So most of the pattern will be shown by your hierarchy, by the parent class, by some of the relationship. Okay, so make sure you can demonstrate the usage of those patterns. All right. Observer pattern also is important. Obviously, it's this whole like a follow relationship. But in this case, it's a little bit special because you only have one thing, which is a user. A user can follow other user. So when you are following somebody else is a subject. So you are observer. You're observing that there's changes. But then the other one can also observe, follow you. So at that time, you will be a subject. So in this case, a little bit special. A user could be both observer and also the subject. So you need to show those in your hierarchy. Okay, so only 4 patterns. Okay, but then you need to use every single one of them. It's a very good practice. It will allow you to really think about how do you fit your application into that pattern. But you don't do that just because of the assignment, because once you have that one, it will allow you to make a lot of changes much simpler. And then the code will looks much more cleaner. But at the end, the very difficult part is integrating those data part with the UI. Okay, so that way you have to understand some of the like UI coding best practice from this framework. Java Swing or Java Flex, all of those are fun, but merging them together. But when we are looking at our pattern, we just mainly looking at the parent classes and the relationship. Great question. How do we specify where to add it? So as I explained last time, you could click on here. If I click on root, then you're adding those into root. If I click on this group, and then it's going to add it into the group. So you click a highlight one, select. Okay, so that's the way you can specify where you're adding a student using the tree to specify that. Top drop down, so user group. It's okay, you can do any kind of a UI, but then as long as you can make sure that we can specify where you want to add that group, and then you can also support multiple level of groups, not just one level. That's okay. All right. So that's why I think this tree view will be the best way to demonstrate it, because it shows you the whole structure, the containment relationship. It's the best way to do it. And then you can definitely use some other drop down or anything. If you think that simplify the process, as long as you have this multi-level containment relationship there. All right. Any other questions about the assignment 2? Okay, you gotta start this early, okay? I'm afraid that you won't be able to finish that within 1 or 2 days. So a weekend probably won't be enough. Okay, if you've never done any kind of UI development before, start a week earlier. Yeah, Ricky, that's good. You should starting today will be very smart. I haven't checked yet. Has anyone finished it yet? Has anyone got it mostly done? Yeah, so this so Catherine, you mentioned about this FX ML. I don't know what that is. So it's basically like a visual builder, right? Visual editor, screen builder. It's fine. Okay, if you want to use that visual editor, I know like a NetBeans has a very good UI editor. Okay, it's okay. Of course, the better way would be to code it yourself, because the editors always generate the code for you, and it makes things really quickly. But later on, when you try to integrate your other code inside, it might mess up stuff, right? So that's fine. If allow you make it work, that's okay. It's fine. We don't prevent you from using this kind of video editor. That's fine. Screen builders, okay. My guess is oh yeah. So that's the one I mentioned. Previously I saw students use that before, so it's fine. Totally okay. Allow you can manage the code changes. All right. And then at the end, okay, don't forget that to simplify our grading, record a short video, okay? Explain, run the demo, see how that works. Even if it has bugs, that's fine. You don't have to show the bugs, okay? Just assume there are no bugs. And then talk briefly about how you implement the patterns, because there's almost no way for us to run like 70 project when you guys use all different kind of frameworks and dependencies. Yeah, Catherine, that's okay, because we're more focusing on the data structure, the hierarchy part. Yeah, so the positive thing is just do your own like logic, okay? As long as you comment that one. For example, just you can pick a bunch of words, some of the positive words. If this match contains that word, then that's positive, okay? It's okay. You decide your logic. Now, if you want to do very fancy sentiment analysis, that's better, okay? I know in Python it's really easy to do. Not sure about Java. I'm sure there are some libraries to do that. Yeah. All right. Um, yeah, I mean, it's much better to just talk very briefly. We don't want to see the long video, okay? No more than 2 minutes. You mainly to run the app, okay? How do you add user stuff, so that we can see the things is running. Again, don't worry that the UI is not well designed. some of the features are broken. Oh, I click on this button, you know, four more times, it's gonna break. That's okay. Okay, that's not really a big issue. We're focusing on the hierarchy, and then when you demo it, you don't have to show us the bugs. Okay, you can assume that that works. Okay, so that's okay. Focusing on applying the patterns, because I know that UI part definitely gonna take some time. So rhyme for a follower, that's okay. In the structures, we don't mind. We're mainly looking at the patterns. So those are how you deal with the storing the user's object. That's your choice. I don't think that affects the design patterns. Yeah, but when you do the update, yeah, you make sure you use the observer pattern to trigger all the updates. All right. Yeah, it's going to be a fun assignment. Okay, if you know how to do this, if you're interested, you can then build like a web Twitter application. Basic the idea is the same, but you just need to deal with a little bit more on the database to persist those information. No, well, so Ryan, I don't get your question. Composite interface, composite has your composite stuff. Okay, observer will have your observer things, and you just need to make sure you follow the pattern. You some of those might be mixed. That's fine. Just like the car example. Okay, we are mixing both composite and video pattern, but we need to be able to see clearly where are those patterns, where those patterns are shown, are applied. Again, there is no unique answer to that. You know, you might come up with different kind of hierarchy, different interfaces. All right. So anyway, focus on the assignment. Okay. I might record some more patterns. Okay, for the coming lecture, so that way, you guys can, you know, first of all focus on the assignment, and then the other pattern you can just go with your own pace. But yeah, I haven't recorded yet, so I will probably do that tomorrow or on Thursday. Yeah, just watch for the announcement. If we do the recording, then we don't have the meet on Thursday, but just watch for my message. I'll try to get a recording done by then. All right, so yeah, this week definitely work hard on the assignment too. If you still have a question about the assignment one, any issues, just feel free to let me know. Yeah, Christian. So I saw the email all the time. Okay, it's sometimes I don't reply. The best way is let's chat about after class, because there were, I remember some of the questions that it's almost impossible to write a answer for that. Okay, it's I may be able to kind of code something for you very quick to show you, but or see your problem. But you know, the best way is let's talk about it, share the screen, and that's the most effective way to communicate, right? So if you get any question, let me know. You know, I normally available before after the class, or if you really need another time, I can definitely figure out a time for you. Yeah. All right. Yeah. For the presentation, it's not really important, I would say. Okay, so we'll do that probably in the final 2 or 3 weeks. I'll pick 1 or 2 weeks to finish that one. That one is allow you guys to also research a new pattern and then to really um, present it. All right. Sounds good, guys. I will, if you don't have questions, I will see you Thursday, or I'll just send you this videos on Thursday.